offer two different credit cards. Card A charges $75 per year and 15% interest on your average balance. Card B charges $15 per year and 18% interest on your average balance. What would your average balance need to be for the cards to cost you the same amount? So what we're going to do here, guys, we're going to forget that this is saying really $75 per year. And we're just going to think of it in terms of a year. Okay, because we know our interest is going to get multiplied by our average balance. So, card A, I'm going to say the amount, my Y, is going to be $75 plus 15% interest on my daily balance. Notice this equation looks a little bit different than the ones we've been dealing with. That's okay. We've set up equations like this before. Card B, the average balance we're going to need to pay is going to be $15 plus 18% interest. So 18% times our average daily balance. Looking at this, if we want to solve this, we could use the fact that this is a 1 here, and that would be okay. But let's do something different. Let's try linear combinations. I'm going to multiply everything over here by a -1. So I'm going to go -1 times y. I'm going to go a -1 times 15, and I'm going to go a -1 times 0.18x. That was pretty easy. Okay. Now, the reason I want to do that, just to kind of show us a different method here, is when we combine them, so we add them using linear combinations, if you have 1y plus a -1y, that's 0. That's okay, leave it at 0. 75 plus -15 is going to be 60. And 0.15 plus a -0.18 is going to be a -0.03. Solving for x, I'm going to subtract 60 from each side. And then I'll divide both sides by a -0.03. And I get x equals 2,000. There we go. Now remember, x represented what our average balance is, because we're going to pay 15% interest on our average balance. So for these two cards to cost me the same, that would mean that I would have an average daily balance of $2,000. What does that mean? Well, I could put this in here now and solve for y, and that wouldn't hurt anything, but we know that this is going to be the same. X represents our average balance. So if we're going to have an average balance on our credit card of $2,000, it doesn't matter which card we pick, A or B. But what if you wanted to know which one to pick? You believe that your average balance is between $1,000 and $2,000. Which credit card should you choose? Well, I know they're the same at $2,000, but what if it's less than $2,000? So remember, a lot of time we said at the very beginning of this lesson that it's helpful to sometimes use a graph. So let's graph these two. This does not lend itself easily to slope-intercept form because we're using these decimals here. So I would kind of make an input-output table. And since we are talking about between the thousands and the 2,000s, I'm going to use those. Okay. So just real quick for this one here. Again, the reason I'm using an input-output table is this doesn't lend well. I don't want to have to graph a slope of 0.15 over 1. If I put 1,000 in for x, what do I get out for y? Well, 75 plus 0.15 times 1,000 is 225. And let's put 2,000 in because that's the range we're looking at. If we put 2,000 in, we get 375. Okay, now let's look at our second equation here. Now our second one, again, guys, I'm going to ignore the fact that these were negative because they weren't negative to start. We just multiplied each side by -1 to start, or to figure out what our x value had to be. So I'm going to do the same numbers here. I'm going to put in 1,000. So I'm going to go 15 plus 0.18 times 1,000. I'm going to get 195. And then I'll put in 2,000. And when I do that, I get 375. So let's plot these. Setting up our scale here, I am just going to go, I think, by hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1,000. If it'll let me write 1,000. 11, 12, 13, 14, 15, 16, 17, 18, 19, 2,000. And if you look at both of these, our lowest is like 195 and our highest goes up to 375. So I'm going to use a bar break and maybe go by 10. So let's start here with 190. And this would be 200. 210, 220, 230, 240, 250. See if I have enough room here. 260, 270, 280, 290, 300. 10, 20, 30, 40, 50, 60. So here's 350. 60, and here's 370. So we'll be pretty close. Okay. So our first line, we're going to graph the point 0, 225 and 2,375. So 1,225 if I can get to write a 0 here. There we go. 1,000, here's 200, 210, 220, 225. It's going to be right in here. And then we have 2,375. 2,000 up here to 375. And then we'll draw a line between them. No idea why it's making that second black mark there, but we'll just ignore that for now. There we go. Okay. And then we'll graph our second point. $1,195. So that's going to be below here. Here's 190. So here's 195. And then we have 2,375, which is the same. So graphing this line, this gives us a visual to see which credit card we'd rather have. We think our daily balance is going to be between 1,000 and 2,000. So which credit card would you like to have? Remember, this represents the amount of money you're paying. If it was me, I want to have the one line in red here because it's a little bit less than our line in blue. So that represents credit card B. So if I had to choose, I'm going to choose credit card B. And the reason is I can see from our graph that if my balance is between 1,000 and 2,000, I would like to pay the lesser amount, or in this case, the line that's a little bit lower than the other one.